Welcome to the lecture video for 3.5 Rational Functions. So one thing to note, we do not cover objectives 1, 4, and 6 in Math 103. Those would be subjects for Math 135 if you go on to that. All right, by definition, let p of x and q of x be polynomials. All right, so just like functions like f of x, where q of x is not equal to 0. A function f of x is defined by p of x divided by q of x is a rational function. And this is why we say that q of x cannot equal 0, because remember, we cannot have 0 in the denominator. All right, so now a good thing to note, a rational, think of the word ratio. Ratio is talking about a fraction, right? So when we say rational functions, we're just talking about fractional functions. For example 1, we're going to determine the behavior of the following rational function. So if you took the equation for a rational function, so any sort of a fraction of polynomials, for example, maybe x over x plus 1, if you graphed this, you'd end up with something similar to the graph I have right here. See the red? That is what a rational function might end up looking like. There are lots of different versions, but this is a generic example. So we're going to introduce some new notation here in this problem. So for part A, it says as x, and then we have a lot of symbols going on here. What do these all mean? Let's take a look. So what this is saying is as x, and we use this word here for approaches. So this is saying as x approaches negative infinity, f of x approaches what? Okay, so let's take a look. As x approaches negative infinity. So x are these values right here, right? Oh, let me get my highlighter out. X, those are the x values, right? Anything along that axis there is an x value. But we're talking about the x values that are specifically approaching negative infinity, which means we're talking about the values as x heads in this direction. Okay, if that was an arrow. So as x is starting to head off to the left, what is our function approaching? Well, if we follow the graph as we move off to the left, so as we move off to the left, this graph starts to look like it slowly approaches a certain value right here. And that value, in terms of y, is going to actually end up being 0. So as my x values get smaller or more and more negative, my y values start to approach 0. All right. Now, let's take a look at the next one. Try to read this off in your head and see if you have the right translation for B. All right, so what is B saying? Well, B is saying as x approaches positive infinity, f of x approaches what? All right. So this time we're looking as x goes to positive infinity, which is talking about moving off towards the right direction. So as x moves towards the right direction, the y values slowly start to approach 0 once again. Okay, so they approach 0. All right, okay, let's take a look at C, and this one has another new symbol in it. The new symbol for C, so what is the plus sign saying? Well, the plus sign is saying as x approaches, let's see, as x approaches, let me highlight that, as x approaches negative 5 from the right. So when we see that plus sign up there in the top, that would be from the right. What is happening to our f of x value? Okay, so let's see, x values, let's go ahead and find them on the graph. So the x values are approaching negative 5. So where's negative 5? Negative 5 is right here where that little blue line is happening, that dotted line. Those are called asymptotes, in case you have not seen them before. All right, so as it approaches negative 5 from the right, okay, so that means we're coming in this direction. As it approaches it from the right, what happens with my graph, f of x? Well, if I follow the red, as I approach from the right, my graph slowly starts to head up and up and up towards positive infinity. So, as x approaches negative 5 from the right, f of x approaches infinity. You could write infinity or you could write positive infinity. Let me go ahead and erase that. And let's take a look at D. Now this one, it looks very similar to C, except it has a negative up above the -5. So what is this one saying? Well, this one is just saying as x approaches -5 from the left. So when we have that little negative up in the top, we're talking about the left. So as x approaches from the left, what happens to our function? Let's take a look. So coming in from the left, my function slowly, remember we're looking at the red, my function slowly starts to head downwards toward -infinity. That was an ugly infinity set. Let me rewrite it. Okay. So it heads towards -infinity. Now we are moving on to some new things. So vertical asymptotes. All right. What is an asymptote? Well, the concept of an asymptote is basically that our line will get slowly closer and closer, our graph will get closer and closer to this number, in our case, -5, but it will never cross it. So if you look at the red lines, they get really close to -5 along here, but they'll never actually cross those lines or touch it for vertical asymptote. That's a thing to note for vertical asymptotes. You will never ever touch them or cross them. However, for horizontal asymptotes, they are similar to vertical asymptotes because your graph will slowly get closer and closer to them, but you do have the option of touching them or passing through horizontal asymptotes. Okay, so slight difference there. Vertical asymptotes come from when our equation is undefined. That's why you can never let it equal those values. And we'll take a look at that closer in the next example. So what is the vertical asymptote? Well, the vertical asymptote is going to be this line here, and what is that called? That is x equals -5. One thing to really note, because the asymptote is a line, you need to write your answer as x equals. If you just wrote -5, you would not get the full points for that, so please beware. Please write it out as a line. Now for the horizontal asymptote, it's going to be that horizontal blue dotted line going across. And where is that going across? That is going across right here. And what line would that be if I was to write that out? Well, that is y equals 0. All right, so we found the equation for both of the asymptotes. Now let's take a look at increasing and decreasing. Well, how do we read increasing and decreasing? Basically, just like how you read a book, you're going to read from left to right and then see if your graph is going up or down. The easiest way that I find to do this is to just trace the graph with my pencil, starting from the left and then moving towards the right and seeing where it goes. So let's go ahead and do that. I'll pull out my highlighter, and here we go. So starting from the left, because remember we read from left to right, I follow my graph, and as I'm following it, notice my graph starts to slip downwards. So this would be a decreasing section in the green. Then I start up again where my graph starts up on the left side. And as usual, I start going, and oh, look at that. Once again, my graph actually is also decreasing. So for G, it says the graph is increasing over which intervals? But notice, neither the green interval nor the yellow interval were increasing. So we would actually say none. The graph is not increasing over any of the intervals. Now for H, the graph is decreasing over which intervals? So we know the graph is decreasing. So for the green part, that starts at -infinity and then stops at -5. It decreases over that interval, and it also decreases over the interval -5 to +infinity. So it's decreasing over both of those intervals. Now, what is the domain of f of x? Remember, the domain is all the allowable x values, and we're able to use every single x value except for -5. That's the only one we can't use. So my domain is going to be -infinity to -5, union -5 to infinity. Now, what is my range? The range looks like it's every value except for 0. So every value except we take out 0. And there we go, we have our range. Okay, so those are some special little facts that we'll look at for rational functions. A very good problem. Good to know the notation for parts A through D. Now let's go ahead and look at the 5-step method for graphing a rational function. So please note, do not use the steps from the book. Those steps are just provided by our book, but the department at WCC would like these 5 steps to be shown. So these are the 5 steps that I'll be grading and that I'll be looking for on your exams. So the first thing we want to do is to determine the intercepts. So that would be x and y. Intercepts. After that, you're going to find any vertical asymptotes by setting the denominator equal to 0 and solving for x. Then we're going to find any horizontal asymptotes. We'll do this by completing long division, just like we do with polynomial long division. Please note, do not use the shortcut method mentioned in the book. That will not receive any points from grading. That is also not what the department is looking for. They want you to use the long division. So I will be grading for the long division. And note, we do not do any slant asymptote problems. What is a slant asymptote? Well, that's just basically when you have an asymptote that is slanted. And we don't do those in 103. We just stick with the vertical and the horizontal asymptotes. Last, we're going to determine the cross touch point. Cross or touch point, if any. And once again, remember, this is for horizontal asymptotes. I'll call it HA. Vertical asymptotes do not have cross or touch points. Then lastly, we're going to graph and determine any additional points if we need to. All right, let's go ahead and use these 5-step methods for example 3. We're going to graph the following function. K of x equals x minus 4 divided by 3x squared plus 5x minus 2 using the 5-step method. Okay, so the first step is to determine the intercepts. So how do we determine the intercepts? For x-intercept, it's always the same. We set y to 0. And then for the y-intercepts, we set x to 0. I'll go ahead and do, let's see, the y-intercept first. So for the y-intercept, set x to 0. So remember, k of x is the same thing as y, so I'm just going to rewrite it as y equals x minus 4 all over 3x squared plus 5x minus 2. When you're solving for these, please show that you are plugging in 0 for these values. So we're going to plug 0 in for x, and what do we have? So 0, 0, 0. We're going to get y equals negative 4 divided by negative 2, which will be y equals 2. So y-intercept is 0, 2. And I'll box my answer there so I can find it easier. Let me go ahead and graph that. 0, 2. All right. Now let's try to do the x-intercept. X-intercept, we're going to set y to 0. So that'll be 0 equals x minus 4 divided by 3x squared plus 5x minus 2. How are we going to solve for 0? Well, let's just put this over 1 and cross multiply. When we cross multiply, that long denominator cancels out and we're left with 0 equals x minus 4. So solving for 4, we have 4 equals x. So my x-intercept is 4, 0. And I'll go ahead and graph that as well. So 4, 0. There we go. All right, we've done step 1. Now let's do step 2, which is determine any vertical asymptotes by setting the denominator equal to 0 and solving for x. So step 2, vertical asymptote. We're going to set the denominator equal to 0, which is 3x squared plus 5x minus 2. Set that equal to 0. Well, that's a quadratic equation. We know how to solve those. Let's try factor it first. So we'll factor it, and let's see, when we factor it, 3x plus 2, and we'll do x and minus 1. So multiplying the, yeah, that would give me the positive 6 and the negative 1 to give us that 5. Yep, looks good. Setting each factor to 0. Remember, we still need to do this when solving. So x equals -2 and x equals, 1 over 3. How many vertical asymptotes do we have? We have 2. Well, now that's interesting. And when you graph vertical asymptotes or horizontal asymptotes, those are dotted lines. So let's say we have -2 and 1/3. So -2 along here. I'll go ahead. I use blue a lot of the time. And I'm going to go ahead and label this. So please make sure to label your asymptote. So it's a -2, and then we have 1/3. That is really squishy, so I'll go ahead and just tuck that in there. Not perfect, but it'll do. And that is y equal 1/3. Okay, so we got our 2 vertical asymptotes. What's next? Find any horizontal asymptotes. We're going to do the division method. Okay, let me go ahead and box this up. We're just running out of a little space here, but we're going to try and keep this as neat as possible. And let me erase this. All right. So the long division methods. That means we're going to be doing polynomial long division, which we practiced before. So step 3. We'll go ahead and set this up for some long division. So we have the 3x squared plus 5x, which is going to be dividing into the x minus 4. The question is, how many times can 3x squared go into x? The answer is no times, which would be 0. Well, that was pretty simple. So my horizontal asymptote, notice I use HA, is going to be y equals 0. And once again, notice the y equals. We're going to use y equals 0, and that is our horizontal asymptote. Let me go ahead and draw that in. I'll use the blue dots. Just use dotted lines to indicate that that's the horizontal asymptote, and please make sure to label it, so y equals 0. Now, let's go ahead and do step 4. What is step 4? Determine the cross or touch point, if any. So how will we find that? Well, to find that, you're going to set your horizontal asymptote equal to your function. Why are we doing that? Well, what we're trying to do is see when does our horizontal asymptote equal our function. That's exactly what we're trying to figure out. If they're equal, they'll cross each other and touch. So for step 4, we're going to go ahead and set HA equal to our function. So horizontal asymptote is 0, and our function is x minus 4 equals, over 3x squared plus 5x minus 2. All right, so putting that over 1, we can cross multiply. And what do we end up with? So 0 equals x minus 4. Ooh, we have 4 equals x. Okay, well, what does this mean? How should we answer our cross-touch points? Well, remember, we're looking for a point. And what this is saying is that x equal to 4, so this is my cross-touch point. I will label it C/T. Please note that. Cross-touch point, we have x is 4, so the question is, what is my y value? Well, your y value is just going to be your horizontal asymptote value, which in our case is just a 0. So at the point 4, 0, we have a cross-touch point, which makes sense because that's actually our vertical asymptote. That's our x-intercept at 4, 0. All right, so far we have done all of the steps except we haven't fully graphed this. So how are we going to graph this? Well, one thing to note is that our asymptotes, the vertical asymptotes, split our graph up into different sections. So the vertical asymptote has split our graph into 1, 2, 3 different sections, and we're going to go ahead and graph each section separately. We'll go ahead and graph the first section to the left. Now, how will we do that? We're just gonna pick a point and see where it ends up using a table of values. So step 5, table of values, x, y. Getting definitely messy in this graph. All right, so picking x somewhere on the left, so that would be to the left of -2. Let's go ahead and pick, let's pick -5. If I pick -5 and I plug that in for y, that would be -5 minus 4 over 3 times -5 squared minus 5 times -5 minus 2. And that's going to come out to what? That comes out to -3 over 16. So where is that? That's going to be down in the bottom below. We don't need to know exactly where it is. So one thing to note, these are just sketches of the graphs. So on your exam and on your homework, you don't need exact points. These are all going to be sketches. To figure out how to graph on the more exact level, that would be in Math 135. So we're just doing approximate sketches for the rational functions. So we know because this is the -3 over 16, it is somewhere down here. Oops, this would be -5. Somewhere down here. So I'll go ahead and write, what was it? -5, -3 over 16. So since my graph is on this side, we have two options for the right side and the left side of our dot. For my dot, I could either go, if I was to take a look at the left side, I'll go ahead and do that in yellow. I can either go up on my dot or down. But if I was to go up, that would mean I'm crossing the horizontal asymptote, which I know I don't do there. So we can't do the top option. The only option we have is to skirt along below the horizontal asymptote. So I'll go ahead and fill in that left side of the dot. It'll be slowly approaching the asymptote, but it won't actually touch the asymptote. But note, it also shouldn't be pulling away from the asymptote. You should just make it up, and there we go, just lightly touching it. Next, we have an option for the left side of our dot. It could either go up, which would mean it would pass through the horizontal asymptote, or it would go down. Well, we know it doesn't pass the horizontal asymptote there, so that option doesn't work, which means we must take the downward option in the green. Okay, so I'll go ahead and draw that in. Take a second, see if you can figure out how we would figure out the middle section. Okay, so for the middle section, we already have a dot. We don't need to use the table of values for this one. So let's take a look at the left side of our dot. It can either go up, follow along, or it could go down. And one thing to note, your graph is always being sucked towards your asymptotes. Think of them as a black hole. Your graph is just slowly sucked towards them. So my dot is either going to go up along the horizontal asymptote, the vertical asymptote, or go down. But if it goes down, that means it's going to have to cross the horizontal asymptote, which we know it doesn't do there. So that means the only option is it must go up. So we'll go ahead and graph it going up along the vertical asymptote, slowly getting pulled towards positive infinity. The next thing we're going to do is take a look at the left side of that middle dot. But the same thing's going to happen. If we were to try to see if it went down, that would mean it would have to cross the horizontal asymptote, which it doesn't do. So we know it's actually going to pop up along the top. A little squishy there. There should be a curve down at the bottom. There we go. All right, so lastly, we're going to take a look at the third part of our interval right here. We have our dot, 4, 0, so we don't actually need to find a dot. Or maybe we do. For the left side of our dot, we can either go up or down. But I don't know which one it is. Okay, that means we're going to have to use a table of values here. So let's go ahead. For the table of values, we need to pick something to the right of 1/3. So let's go ahead and pick 2. That's a nice small number, pretty simple to work with. So we'll go ahead, pick 2. Plug that in. So we're picking 2, plugging it in, we have 2 minus 4 divided by 3 times 2 squared minus 2 times 2, minus 5 times 2. minus 2. And what would we get if we plug that in? It's about negative 110. Okay, that means it's going to be down below in the third quadrant. Sorry, in the fourth quadrant. So we're going to take the bottom root. It goes down. How do I know that? Because we have that negative 110, so I know my graph must be down in the negative quadrant. And I know it's not going to pop back up because we don't have a cross touch point there. Lastly, I need to take a look at the right of my dot. Two options. Possibly it's below my horizontal asymptote and it skirts along below. So something like this. Or it's above my horizontal asymptote and it skirts along above. How will I know which option it is? Once again, we're going to use a test point. So picking something bigger than 4, let's pick 5. So plugging that into my equation, I'm going to try to figure out which side or where my point is going to be. And what will I get this to come out to be? That comes out to be 1 over 98, which is a really strange number. But the main thing I'm looking for in this problem, that looks like it's going to be above my horizontal asymptote. In our case, because it's positive. That's not always the way to figure it out, but we know it's going to be above our horizontal asymptote. So that means the bottom option is not what we're looking for. That means it pops through. Ooh, so in this case, is it a cross or a touch point? It's going to be a cross point because it goes straight through the horizontal asymptote and starts to follow it along the other side. Okay, so it goes straight through and it follows along the other side. So this point here at 4, 0 is actually a cross point. Alrighty, so that's it. Those are all the steps for graphing a rational function. If you've got any questions about the homework, please send me an email.